Hi guys, welcome to your lesson today on factoring polynomials using what we call the greatest common factor, or GCF. So here's kind of our overview for today. Your goal for today is going to be to identify a greatest common factor and then to factor out a greatest common factor out of a polynomial. So our agenda, we're going to start with a warm-up like always. We're going to identify greatest common factors and define greatest common factors. That's a little bit of a review. And then we're going to factor out GCF and we're going to try some try problems. All right, so as you go through this video, please make sure that you have this factor and greatest common factor note sheet, or you could be taking down these notes on paper. All right, so we're going to start with a warm-up. This should be a little bit of review. So these first three problems here, factor the quadratic trinomials. So at this point, please pause the video, try these three problems, and then pick it up again and check your answers. Okay, so now that you're done this warm-up, check these answers. And keep in mind, when we factor these quadratic trinomials, we're factoring them into two things that are being multiplied together. So for example, number one is x plus 5 times x plus 4. It doesn't matter what order we multiply in. So your answer could have been x plus 4 times x plus 5. That is the same thing. The same for number two. Number two could have been n plus 2 times n minus 7. The order doesn't matter when we multiply. All right? So let's move on. Just a quick review. We're just going to kind of review greatest common factor. Keep in mind, a greatest common factor, the definition, is the biggest number or the biggest term that divides evenly into all the numbers or all the terms, okay? So this should hopefully feel like review to you. We've done this before earlier in the year, but we're going to identify the greatest common factor of a bunch of different problems here, all right? So 12 and 36, I'm on number one here. What we could do is first list all the factors of 12 and all the factors of 36. So all the factors of 12, 1 times 12 is equal to 12. So 1 and 12 are factors. 2 times 6 is equal to 12. So 2 is a factor, 6 is a factor. And then we know that 3 times 4 is equal to 12. So 3 and 4 are both factors, right? All right, let's go on to 36. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6 gives you 36. So all those numbers are factors, right? So all we did here was list the factors. Now we want to find the greatest common factor. The greatest common factor is the biggest factor that these all have in common. So 12 and 36 have a bunch of common factors: 1, 12, 2, 6, 3, 4. But we're looking for the greatest common factor, the biggest of these numbers. They both have 12 on the list, right? And that's the biggest number. So therefore, our greatest common factor is 12. All right. Number two, we're looking for x and x squared. Well, factors of x, the only thing that gives you x is 1 and x, right? Factors of x squared, the only thing that gives you x squared can be 1 times x times x. So what do they have in common? They have the 1 in common and they have the x in common. So for number two, our GCF is 1x, or in other words, just x. Number three, now we have the coefficients and the variable parts here, right? We have two different parts, the numbers and the letters, basically. So let's look first at the 5 and the 10, and then we'll look at the x cubed and the x. All right, so let's list all these factors. Factors of 5, just 1 and 5. Factors of 10, 1, 10, 2 and 5. Factors of x cubed. Now, x cubed could be 1 times x times x times x, right? X times x times x gives us x cubed. Factors of x, just 1 and x. So we're going to see what the numbers have in common and then separately what the variables have in common. The biggest thing that these numbers have in common is the 5. And then the variables just have the 1x in common. So here our GCF is going to be 5x. All right, number 4. So again, we have like a numerical part here. We have the coefficients and then we have the variables. But not only do we have one variable, we have an x cubed and an x squared. So we have the x part and then we have the y part, right? So 12, we already listed those factors up in number 1. So let's just list them again. Right? 8. To get 8, we can multiply 1 times 8 or 2 times 4. X cubed can be 1 times x times x times x. X squared is 1 times x, right? Y squared, 1 times y times y. Y to the 5th, 1 times y, 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 y. 1, 2, 3, 4, 5 y's, right? So what do they have in common? The numerical part, our biggest number part here, is the 4. The x's, now look, they have 2 x's in common. And the y's, they also have 2 y's in common. So I know I'm kind of squeezing things in here. But our GCF is going to be 4x squared y squared. All right? So now what I want you to do is I want you to try these 2 you-try problems on your own. Pause the video, and then when you resume it, you can check your answers. Okay, so now that you've tried those you-try problems, check these answers. Now, what are we going to do with this greatest common factor here? Why did we just go through all that? So what we're going to do is we're going to learn a new type of factoring method, okay? So this is called factoring using the greatest common factor. So sometimes you may have a quadratic trinomial that looks something like this. This here, 2x squared minus 10x plus 20, right? What do you notice about each term in that polynomial? Hopefully, you noticed that each of these terms can be divisible by 2. 2x squared, negative 10x, and 20 are all divisible by 2. They have a GCF of 2. So what we're going to do is we're going to factor that greatest common factor. Okay, so let's go through these steps down below here, these 3 steps right here, and we'll follow these steps to factor this polynomial that we've underlined in blue. So step 1, identify the greatest common factor of all the terms in the polynomial. So we just said that our greatest common factor is 2. Notice it's just 2. It's not 2x because not all 3 of these terms have an x, right? This 20, that doesn't have an x there. Okay, so my GCF is 2. Step 2 is to divide each term in the polynomial by the greatest common factor. So let me get rid of some of this stuff up here. So we're going to go back and we are going to take each term in the polynomial and, like it says here, divide each term. So we're going to divide by 2, divide by 2, and divide by 2, okay? But we're going to write our answer in this form. This is the important part, okay? Well, it's all important, but this is how our answer is going to look like. We're going to write the GCF out in front times whatever we have left over when we divide. So our GCF was 2. I'm going to write that out in front, and then I'm going to write a parentheses. And in this parentheses, I am going to divide, kind of like what we wrote up here. So what is 2x squared divided by 2? 2 divided by 2 is 1, right? But I don't really need to write the 1, so it's just x squared. Negative 10 divided by 2, that gives me negative 5x. And plus 20 divided by 2 gives me plus 10. So notice, again, I have my greatest common factor out in front. That's this 2 here, okay, times, and then in parentheses, what I have left over when I divide. Step 3 is to continue to factor if possible. We're going to kind of get to that step next time we talk, all right? But I want to take a minute before we go any further and just kind of show you what we're really doing here. So as you can see, the key word here is that we're dividing. Factoring is kind of like dividing. What's the opposite of dividing? Multiplying, right? You know how to multiply polynomials. We've gone through that. If I were to take this right here and tell you to multiply, this is, you should think like distributive property in your head. You can distribute this 2 into the parentheses. So 2x squared, 2 times negative 5x is negative 10x. 2 times 10 is plus 20. What do you notice? This right here in red gets me back to my original problem that we factored, right? So factoring and multiplying are kind of like opposite or inverse operations, all right? But I don't want you to, you can think that in your head, that can be like part of your ways to check, but if we ask you to factor, this is your final answer for factoring, okay? That's your final answer. All right, so now that we've gone through one problem, let's go through a couple more examples together, okay? So factor completely. So number 1, 2x minus 4. Again, I need to identify my greatest common factor first. So my GCF. What goes into 2x and negative 4? My GCF is just 2. So we put the 2 out in front. We put the greatest common factor out in front. And then we draw a parentheses and we divide each of the original terms by that GCF. 2 divided by 2 is 1. So this is just 1x, but remember, we don't really want to write the 1. We just need the x. And then negative 4 divided by 2 is negative 2. So my final answer is 2 times x minus 2. Again, to kind of check your answer, think in your head. If I were to multiply that 2 back into the parentheses, this 2, if I distribute that back in, I would get 2x minus 4, which is the original problem, right? All right, let's try number 2. So our GCF, what goes into 12x squared and 4x? Well, 4 goes into 12 and 4, and x goes in to x and x squared. Here's a little hint. Hopefully you picked up on this, but when you have variables, the GCF is always going to be the smallest exponent of that variable. So x squared and x, the GCF is going to be x to the first. Let me go back over here for a minute. You can see in our example problems here, like in number 3, right here, x cubed and x to the first. So my GCF is x to the first. In number 4, x cubed and x squared. My GCF was x squared. And then the y's were y squared, y to the 5th. My GCF is y squared. So I can always kind of just use the smaller exponent, all right? Anyway, going back to number 2 here, okay? So my GCF is 4x. I'm going to put the 4x out in front, divide each term by 4x, and write it in parentheses. So 12 divided by 4 is 3. When I divide with exponents, remember I subtract the exponents. So x squared divided by x, 2 minus 1 is x. And then negative 4x divided by 4x. When you divide anything by itself, you get 1, right? So these whole things cancel out. This whole thing turns into a 1. So this will be 3x minus 1. Circle that. That's your final answer. All right, let's try number 3. So number 3, our GCF, what goes into 18 and 20, my GCF is 2. They don't both terms have an x, but they do both have a y. So my GCF is going to be 2y. So I put the 2y out in front. I divide each of these by 2y. 18xy, the y's cancel. 18 divided by 2 is 9, and that x is going to stay there. 20 divided by 2 is 10, and then the y's are going to cancel out. So here my final answer is 2y times 9x plus 10. Number 4. So here my GCF is just going to be x, right? So I put the x out in front, divide everything by x. X cubed divided by x is x squared. Remember, again, we can subtract the exponents, or you can kind of think like x cubed is x times x times x over x. One of these x's cancels out. You have 2 left. Hopefully you remember this from our exponents unit. Minus, these x's cancel, 6. Circle that. There's your answer. Number 5, your GCF is going to be 4. Put the 4 out in front. Divide each of these terms by 4. 4 divided by 4 is 1. So this is just x squared minus 2x plus 2. Number 6, your GCF. This one might be a little tricky. You don't have any, the coefficient of the first term here is just a 1. So no numerical part for my GCF, but my variables, my GCF is going to be x squared because they all at least have 2 x's, right? Put the x squared out in front. Divide each of these terms by x squared, and you have x squared plus 7x plus 5, because the x squareds cancel all together there. There's that final answer. All right, now that we've gone through 6 example problems together, there's a bunch of you try problems at the bottom of this page, 10 problems. I want you to pause the video, try these 10 problems, and come back and check your work, and then you'll be done for today's lesson. Okay, so now that you've done these 10 you try problems, take a minute. You'll probably have to pause this again here so you can see this screen for a couple minutes and check all of your answers. One other kind of trick that I wanted to show you guys. If you look at like number 5, I want you to notice that in number 5, both of these terms are a negative. So sometimes we don't just say that our GCF is 6r to the 4th. We say that the GCF is negative 6r to the 4th. So sometimes we actually might take out a negative 6r to the 4th, and then what's left in parentheses is a positive r and a positive 1. So if you had written your answer that way, that would be fine too. The same thing with number 9. You might, we kind of call that factoring out the negative. We might want to factor out the negative in number 9. So you could have your answer as negative 4 times positive 7v squared plus 2v plus 9. Either of those is acceptable. So now that you've checked all your answers, hopefully you have a good grasp of factoring polynomials using the greatest common factor. Thanks, guys.